Okay, today we are going to look at beat frequency. So beat frequency, this comes about when we have multiple frequencies being sounded at the same time. So two things that you might hear is you hear this word of consonance and dissonance. These are more musical terms about how those two frequencies sound together. Do they sound harmonious or not? We're going to focus more in on beat frequency. This is when those two frequencies that are sounding are relatively close together, meaning less than 15 hertz apart. So those frequencies are very close together. When that occurs, we get this phenomenon where we hear a frequency in the overall intensity of that sound wave. Okay, so let's go ahead and let's listen to that sound wave, and then let's go ahead and take a look at what's actually happening with those wave functions when they are mixing together, just to see more of a visual and an audio representation of a beat frequency. Okay, now we're going to listen to what it sounds like to hear the beat frequency. Now remember, when we're thinking about the beat frequency, we're listening for a change in the intensity of that wave. So essentially the volume, how loud it is. So when I play these two tones, they're going to sound something like this. And they are 1 hertz off from one another. So what that means is that when I play them, we should hear the intensity changing about once every second. So you should hear it kind of as a wah, wah. Okay, so let's go ahead and listen for that. Okay. All right. So let's go ahead and look at what that looks like on a calculator as well. All right, we're going to look at how that graph looks for a beat frequency. So what I'm going to do is I'm going to graph two frequencies at the same time. So here I have two sine curves that I'm going to graph at the exact same time, and I'm going to add them together, and we're going to see how do those two frequencies play together. So here we have them interacting, and what happens is in some places they're completely out of phase, meaning they're canceling each other out. And in other places, they're completely in phase and adding together. And so we see that we get these pulses of higher and lower intensity. And that is the beat frequency, the frequency with which it is increasing and decreasing as it goes on with time. So now we heard that sound going, we heard that beat frequency. We also saw that change in amplitude of that combined wave of sound. And so how do we find the frequency of that new beat? And so how you find that beat frequency is we go ahead and we take the absolute value of the difference of those two frequencies. So we take the difference of those two frequencies, take the absolute value, and we find the beat frequency. So the beat frequency tends to be less than 15 hertz. The reason it's less than 15 hertz is that's what's audible to us. Once you get past 15 beats per second, it starts to turn into a different tone, meaning we hear it as a third frequency in the mix. Okay? So let's go ahead and try one of these out. We'll try an example here. So I have a beat frequency of 4 hertz is heard when listening to a known frequency of 220 hertz. So what's that other frequency out there? So let's go ahead and let's use that equation we have. So I say that there's 4 hertz, so the beat frequency was 4 hertz. And one of the other frequencies was unknown, let's say. And then F2, let's say, was the 220 hertz. Okay. So we want to figure out what was that unknown frequency if we know one of them. So what we can do is we can set this up and solve it. So I have the beat frequency is equal to the absolute value of F1 minus F2. And so I can take the absolute value off, make it plus or minus on the other side, and move the F2 over. So I have F2 plus or minus FB is equal to F1. And so I can see then if I do 220 plus or minus 4, I'll get the beat frequency. So is there not only one possible frequency it could be, there's multiples. That means my frequency could be 216 hertz, or it could be 224 hertz. There's multiple ones. So how can you tell? one thing you can do then is get a second reference frequency. So, okay, it sounded 4 hertz at 220. Let's say I play 224 hertz with it. Well, if it plays 8 hertz, you're automatically knowing it's the 216. If it plays 0, you know it's 224. So you can use this actually, I'm not sure if they do it now, but they used to use this to tune pianos. They would listen to the tuning fork and listen to the string in the piano, and they'd listen for that beat frequency, tune it, and if it got a higher beat frequency, they were going the wrong way. A lower beat frequency, they were going the correct way. So that is beat frequencies.